Video will be going over creating a simple pushdown state machine within Unity with its core emphasis is working with UI. Um, Once this project's over, all the code should be available in the description off of GitHub, and I'll toss down in the description any links that might find useful or things that I state within the video as we go on. So let's begin, and I'll talk us through it. First off, I'm just going to set up my project and just create a couple of folders just for later on for sanity's sake. And in here, I'm just tossing everything into my state machine folder. Now, to begin off, let's create two C# scripts. One will be UI state machine, and one will be UI state. And let's open them both in whatever editor you have. Actually, get both. And I don't need this. First off, we'll start in the UI state to implement just the core things that we need. For my implementation, the state is what we're going to be inheriting from for any UI states that we'll have later on, such as your main menu, options, new game, anything simple along those lines. This class we're never going to be using in-game, so I'm just going to be calling abstract because you should always inherit from this to create your own. First thing we're going to be having in here is a property, and it's just going to be a public abstract int state ID. This will be the ID of the state and be used for setting up the state machine and accessing the state later on. Also, I'm going to create a private variable of UI state machine. And this will be the state machine controlling the state. I'm also going to create a public property of UI state machine so we can easily access this. And this is only going to return the state machine. Now, I also have a simple virtual method in here that we're going to create. It'll be a virtual string, and this is just get state name. Self-explanatory. You can override this in your own state to pretty much just get this. This is mostly for debugging purposes. I'll just return UI state as the base. And finally, I'm going to create a private void awake. In this awake, this is all our initial setup and tying this UI state to the UI state machine. And pretty much I do this all here so I don't have to worry about it later on. And you won't be, if you're thinking that you might want to use the awake method in your inherited state, just wait a little while and I'll show you what all methods we're going to be using and how we implement those. We're not actually going to use any of the mono behavior predefined methods such as awake, update, or start. But in here, we're going to pretty much assign our state machine to this .gameObject.getComponent and parent, and we will do of type UI state machine. So the way this is going to be assigned in our actual UI hierarchy, we're going to have our UI state as the parent game object, and every individual UI state will be child to the UI state machine. And in here, we'll just grab the UI state machine from a parent. Also in here, we'll be checking if the state machine is null after we do this. We're just going to do some debugging code and log a warning. And in here, I like to do string format so I can get all this nice. And let's see, requires parent game object to have a UI state machine component attached. And I'll use this GameObject.name as the first, as this element. And if it's not null, I'm going to call our state machine dot add state. This is a method that we haven't implemented yet, so this will just call out an error, and we'll jump over to our state machine now and go and implement this. Over in our state machine, we'll just go on, we'll start off at the start. Actually, the first thing, since our state machine is going to be using stacks to control our states and what order we assign them and which one's active, we're going to be using the system collections.generic. And up here at the start, I'm going to be using a couple variables. These we'll use later on in this class. First off, do our private stack, which will be a stack of all our UI states, and I'm just going to call this underscore UI stack. And also, this will just be another private assignment dictionary int UI state. I'll call this UI states. So this underscore UI states dictionary that we have here, the int is going to be the state's ID. That's the value we're going to be using inside our state machine to access this. The UI state is the instance of the state from the hierarchy that will pretty much from in this awake of the UI state, it will be calling the add state, which in here we'll be adding that state to this dictionary. And we'll go straight into that method right here so we no longer have any errors. So we will come over here. This will be a public void add state UI state, and I'll just go state. And here we're going to do if state equals null. We're going to debug a warning again because I like doing all this double checking. And in here we'll do the same format. Adding null state to UI state machine. This.gameObject.name. And we're just going to return. We're not going to add anything null to this whatsoever. Down here, we're going to do if not UI states dot contains key state dot state ID. So if the states dictionary does not already contain the UI state we're trying to add's ID, we're going to add that state to the state dictionary with the state.state ID as the key and the state as the value. And before I forget, a method that I normally always create for these, this will be a private void. I'll just call this validate. state machine. Because sometimes the order which Unity calls certain model behaviors is in different orders. So sometimes if we have different awakes, their order of being called can be different. So I got into the habit of creating methods which will check for everything. So in here, UI stack equals null. We'll do UI stack equals new stack of UI states. We'll do the same for the UI states dictionary. We'll check if it's null. And if it is null, we'll assign it to a new dictionary. Now, this method will always just double check, and if it is empty, we'll do it. So what I do is whenever I'm accessing either of these two, I just call this method within the method accessing it. So in here, I'm using UI states. So I'm just going to call validate states to double check. You can do a little bit different organization, but this is something I found that usually works and is relatively clean. Now that that's out of the way, I'm going to start implementing some of the methods that's normally used with a stack. A couple of the major ones. We'll just write out the methods first, but we're going to have public push state, which will take a state ID. Public void pop state, which will have no parameters, and a public UI state peak state. These are the three main methods. If you haven't used a stack before, I'll post a link down in the description with a little bit more information on it. But in general, the push state will push whichever state we're patching on top of the stack. The pop state will remove the topmost state from the stack and give it back to us. The peak state will give us the topmost UI state from the stack, but it will keep that state on top of the stack without removing it. The pop state will remove it from the stack. And in each of these, we'll just start with the peak state to begin with. Also, this peak state, since it's it's telling us which one's at the top of the stack, we'll be using this method to tell us which is our current state of the state machine. So we'll just implement it from peak state up. And here, we're going to be calling validate state machine because we'll be accessing the stack. And we're going to check if the stack's count of states currently in it is greater than 0. So there's something on the stack. We'll return UI state, no, not state, stack dot peak. And if we don't return that, or if the count's not greater than 0, we're just going to return null. Also, feel free to rename any of the variables to whatever suits your fancy. These two names are kind of close and a tad bit confusing, but they get the job done. Next up, the pop state. We're going to validate our state machine again. And if UI stack dot count is equal to 0, we're going to return, because we can't pop a state if there is none. Now, in here, we're not actually going to do much just yet, since we're going to be implementing all our events and calling our UI state in a second, but I'm just going to implement a few of the little things. So for now, you can use UI state, previous state, or the previous state, and we will call our UI stack dot pop. This will remove our current state from the top of the stack. And then our push state. And here we'll do the same with the validate state machine. This time around, we're going to do if let's see, 1 second here. Yeah. Oh, yeah. Excuse me. We're going to create one. Let's see. I'm going to create another method down here just for helpfulness, since I'm not going to write the same code multiple times and we'll use it later. And you may want to use this outside of the state machine, but contains state method int state ID. This method is just going to check if we have the state in our state machine. So validate state machine, if not UI states dot contains key state ID. We're going to debug some more warnings, because who doesn't love a good warning? This will just be push state ID 1 does not exist in the UI state machine. This.gameObject.name and state ID. And we're going to return that it does not contain the state, so return false. Else will return true. So this is checking our dictionary of states, and if we don't have it in there, we can't actually push it onto the UI, onto the stack, because we can only push anything inside our dictionary onto our state. Now we'll jump back up to our push state, and we'll just continue. If we did not contain the state of state ID, we will return, because we cannot push a state that we do not have in our dictionary. In here, we're going to do UI state. This is our next state equals UI states with the key of state ID. And if the next state does not equal null, UI stack dot push next state. So we grab the UI state from our dictionary, we double check if it's not null, and if it's not null, we push it onto our stack. That's all the push does. And we will implement 2 more methods that will be useful later on when we actually start doing our using of the state machine. So, public void clear state. Clear states, yeah. This is useful. We remove every state from the stack. And in here, we'll start just implementing it. Another validate state machine. And we will, for the most part, for just to lay the framework for the later events that we'll be implementing, we're going to do UI state, previous state, and we will just peek the state off the top of the state machine. Because the previous state is now whatever is on top since we're clearing it. If it's not equal to null, in here we'll do some event calling. But for now, that's nothing. And while UI stack dot count is greater than 0, so now this is going to go through every single. Well, this will continue looping until all the stack is empty. But in here, we're going to do a UI state, temp state, because we're just going to loop really fast and go UI stack.pop. So we're just going to loop through here, popping every state off the top of the stack until there's none remaining. We're also going to be calling some more event stuff within the while loop. And down here, just to clean everything up, you can do clear. That'll just call the default stack clear, just in case if we miss something, but we shouldn't have. Also, one other method. This one you can use if you want to force moving between two states. And this one will just be set state, int state ID. Now, personally, you won't really use this often. You'll use other methods in here, but this is when you have, let's say, a stack of 4 states, and you want to transition to, let's say, your default state, which is either at the bottom of the stack or not even in the stack anymore. So the set state will clear out all states from the stack and then set the current state to the one that we supplied. So in here, this is a really simple method. We're going to check if we contain the state that we're being passed. If we do, we're going to clear all the states, and then we're going to push the state that we passed. That is all we do for set state. So if we have all the other methods set up to handle everything else. And now I'll move on to my fun implementation of all the events and how those will be handled within here. So back to Unity. And in here, I'm going to create another folder and call this interfaces. Now I'm going to be using interfaces to handle my events. So the way we're going to do this is when you inherit from the UI state, you can also inherit from one, two, or several of these interfaces that we'll be creating. Depending on which ones you inherit from, or implement, I should say, the interfaces, that is what methods will call on your class. So you choose which ones that we're going to be calling, and we're just going to check, hey, does this class actually implement this interface? And if it does, we'll call the corresponding methods. So I've set up, or my plans for this anyway, I have about, I think it's 6 or 7 interfaces that we'll create. So let's just keep going down the line. I have on state awake. So a couple of these are going to be implementing or mimicking the Unity's methods for their mono behaviors. I have on state enter, on state exit, on state update, on state focus, and on state defocus. Now, if you're looking at these, you might think enter, exit, focus, and defocus. That those kind of sound like they do roughly the same thing. And in some instances, you're right, but in others, they actually have different purposes for how I see it anyway. I'll try explaining it in a second after we implement all these, and once I'll show you how these actually work. Now, I'm going to open up all of these in my editor. So, click all of them open. And now we have them all up on top. Now, for each of these, I'm going to try and do this relatively fast, but we're going to change it from class to interface. And then we remove everything and just add a curly bracket. And that's all we're going to do. I'm also going to actually, I'll just do this. So I'm going to do this fast and jump through each one of these, copy pasting. And jump back, grab these curly brackets, just paste. And yeah, I think I got all of them. Okay. Now, we're just going to step through each one of these and use some names. These are going to be really simple, and again, you can rename them to whatever you want, and it should work. Just remember to use your name once we start using these other places. So, first off, we're just going to do void on awake with nothing. That's all we do. We don't have to do our access modifiers, anything like that. You can assign it on your class yourself. Jump over to defocus, do the same, void on defocus, no parameters. And we'll do this for each other one. So void on enter, void on exit, void on focus, void on date. Cool. Have all of those. And now we'll jump over to the UI state machine. We will implement all of these through the UI state machine, and then once we're done with that, I will step through and show you how to implement your own UI state using a couple of the interfaces, but that may be in the second video if this is too long. Okay, down at the bottom of our UI state machine, we're going to create several event methods that we'll just use within the UI state machine, which will all be private voids, and I'll just call them pretty much the same name as the interface's method inside of it. But these will take a UI state. These are just to make the handling code easier so we don't have to write much in other places. So in here, I'm going to write a I on state awake, the interface, and this will be, I'll just call it I, equals the past state as I on state awake. So all this will do is take the state we pass and try to convert it to the interface. This will be checking, and then it will assign it to the variable. Our next line, so if I does not equal null, this means the state that was passed implements this interface. So if we called I dot on awake, we can call that method off the class. So this way, we're just checking if the class inherits from or implements this interface, and we'll call the class without much work. So it's easy enough. And in other parts of our code, we can just call this method and pass the state that we're attempting to call this on. And if it doesn't have this, No big deal. We'll just skip it. Now, copy and paste this 5 more times. And we'll implement the other ones that we created. Just go awake, update. Actually, can I do this faster? Faster is always better, usually. Awake to update, replace all, find all here, awake to enter, awake to exit. Oops. Oh, I was forgetting to include the method name as well. Awake to focus. And awake to defocus. Now I need to jump back up here and fix a couple of these that I missed. And there we go. Now we have all of these. These will pretty much be our events that we'll be calling. And now we'll go down all our methods that we created and start implementing. And we'll start with our simple update method. So we're going to do our UI state, our current state equals peak state. If our current state does not equal null, so we actually have a state to work with, we'll call our onUpdate method on our current state. And that will check if it implements the update interface, and if it does, it will call it. Next, we'll jump down to our push state. And here, before the next state, we're going to do UI state prev state. And this will equal peak state. So whatever the current topmost state is. We'll check if there is a previous state. So if it's not null, we'll call on defocus. So here's where I need to explain what our defocus and exit means. So, and our enter and focus. So when we push a state onto the stack, so if there was nothing previous, we would call on enter and then on focus, because this state is currently on top. But the thing was, my idea behind it is if we take something off the stack and there is a state underneath it, we're going to be calling focus because that state comes back into focus and we'll be using it again. Because a state can come into focus and out of focus a lot if we keep putting stuff on top of it and removing it. Now, enter and exit. Enter comes on when we put it onto the stack. Exit is when we remove it from the stack. So there's no longer any state on there. So both of them kind of, in a way, talk to each other. But if a state has something popping on top of it a lot, then the focus and defocus come into play a lot more clearly. Anyway, you'll see how that works when we start implementing a UI. Next, we'll come down here to our next state, and in here, after we push it, we'll do our onEnter, as I was talking about, on the next state, and also our onFocus next state. So we're pushing on, we'll call both those methods. Now down to our pop state. This one we're going to add a lot more stuff. So our previous state in here, we're going to check if it was not null. If it was not null, we're going to call on defocus, pre-state. And on exit, because we are popping it off of the top of the stack. Also, we're going to have another UI state, which is next state. Which state are we going to? This will peek off top of the stack. And if this is not null, we're going to do on focus of this state. And hopefully my explanation of this is clearly enough that you'll see my reasoning between on focus and on defocus. Then next we'll jump down to our clear state. This one will have some more event calling to remove this comment. And inside here, we're going to defocus this state since we just peeked it off the top. Now, the state's still here, but we're just going to come in here and it's going to get popped. So in here, we're going to do on exit. My reasoning for just doing this on exit on every state in the stack, because I don't think we really feel like the defocus is going to come in handy here, because we're just removing everything fast. This on exit is more of our cleanup method when we're done with a state at all. And you want to, when we're done with it. Simple as that. If you feel like you want the defocus called on everything when you cleared, go ahead, add it here. And let's see. Also, what's this? Down here in our add state, this is when it gets added to the state machine. So in here, I'm going to be calling the onAwake after everything's been added and the state is finally active and ready to go. State. And that is actually everything for the UI state machine. Oh, I almost forgot. One additional thing to make our lives a little bit easier later on when you're running this, and it actually works. We're going to come in here and do a public UI state initial state. The one state that will start when the state machine begins. In the Unity UI, you'll just drag and drop which instant you want here, and it will double check it against our dictionary and then run it. Also, you could change this to an int and use it as a state ID and do the same thing and change it that way. And then you don't have to drag and drop. You can just do whatever value you want that way. I find it easier for the state itself. In the start, we'll do validate state machine. We'll check if the initial state is not null. We'll also check if we contain the state in our dictionary. And if we do, we'll push the state. Also, because I like being thorough, we'll do some debug warnings, because warnings are awesome. Initial state value is not childed to the UI state machine. Start.game.name. Oops, I forgot my string.format. And I'll do a little bit of formatting myself. There we go. Now that is everything to our state machine. And that's it. Well, I'm going to end this video here, and in the next video, I'll go through implementing a simple UI and inheriting from our UI state machine. Until then, thanks for watching.